Hey guys, this video is just going to finish the notes that we started in class. We were able to do A and B in the room, so let me show you how to approach C and D. C doesn't have a whole lot of numbers, but if you remember back to how we handled these two problems, or specifically B, we tried to factor these as much as we could to make life easier on ourselves. So you can still do that even if you're dealing with a polynomial, like a quadratic, because these are both quadratics, right? Both start with a squared term. So I still have my A, can't factor that at all, but I could factor A squared minus 25. Remember, A squared minus 25 is really just A squared plus 0A plus 25. So I'm looking for things that add to 0 and multiply to 25. That's going to be negative 5 and positive 5. So I'm just double bubbling because I can. Times A squared plus 2A minus 15. Can we double bubble that? Well, we're looking for things that add to 2 and multiply to negative 15. So that's going to be A plus 5 and A minus 3. And then this A minus 3 we can't do anything about. Can't factor that any further. So when you multiply two fractions, like for example 2/3 times 4/5, you multiply the top, the numerators, and you multiply the denominators. So 2/3 times 4/5 is 8/15, which means that this expression can all really be written as one big fraction. So A times A plus 5 times A minus 3 all over A minus 5 times A plus 5 times A minus 3. And at this point, we can start making life really easy on ourselves by factoring things, or canceling things, rather. So what things here equal 1? Well, if I divided A minus 3 by A minus 3, that would equal 1. If I divided A plus 5 by A plus 5, that would equal 1, and I would just be left with A over A minus 5. Can't factor that any further. All right, so our takeaway here is going to be that we can factor polynomials just the same as we can with numbers to help us simplify these fractions. All right, now let's do example D. So D is the same type of thing as what we did in C, except you'll notice we've got a fraction being divided by another whole fraction. So to do D, we're going to have to remember a rule. Let's use our fractions 2/3 and 4/5 here. If I were to divide 2/3 by 4/5, there's a rule that we can apply here to make things really easy for us. 2/3 divided by 4/5 is the same as 2/3 times 5/4. So the rule here is something we call keep, change, flip, which really just is another way of saying that if you divide a fraction by another fraction, that's the same as multiplying that numerator fraction by the reciprocal of the denominator fraction. Those are the same thing. All right, so let's apply that here. We've got x squared minus 16 over x squared minus x minus 20, and I can multiply that instead by the reciprocal of the denominator. All right, now it's basically the same type of problem as what we had in the previous example. I should factor these two, this x squared minus 16 and this x squared minus x minus 20. X squared minus 16 can be double bubbled to x minus 4 and x plus 4. And remember, when I multiply, I'm just going to multiply my numerators. So let me rewrite this as one whole fraction here. So just in case you're confused, this fraction here is these two, and that is the x minus 4. That's why that's in our numerator. Then I'm going to double bubble the x squared minus x minus 20. I'm looking for things that add up to negative 1 and multiply to negative 20. So I'm thinking x minus 5 and x plus 4. And then I still have this x minus 4. So now I can start canceling things if we've got anything that equals 1. Well, x plus 4 divided by x plus 4 would equal 1. And x minus 4 divided by x minus 4 would equal 1. That's going to leave me with x plus 4 over x minus 5. Nothing else we can do about that. Okay, so our takeaway here is going to be keep, change, flip. All right, and that's our rule for when we are dividing by a fraction. And for me, sometimes it helps when there's a rule like this to show an example of how it would be used, using real numbers, or you could use variables there, something that would remind you in the future. All right, so that should do it for getting us through the end of these notes. It is not an easy homework assignment, so I'm just expecting that you guys put the effort in and attempt every problem to the best of your ability, but we're going to be doing a ton of practice in class on Monday. All right, so good luck, guys, and I'll see you Monday.